Okay, hi guys. Today we have a nice limit problem. So the question is that a sub n is a sequence and a sub to n times a sub to n plus 1 minus 2 times a sub to n equal 1 minus 6n over 1 plus 6n. If so, find limit n approaches infinity a sub n. So we have to find this limit. Okay. So, looking at this expression, it's not hard to notice that first. We know that, okay, A is a sequence, so we have to first define if A is this expression, the sequence is increasing or decreasing, or not increasing nor decreasing, or monotonously increasing or monotonously decreasing. We have to first try to understand. Okay, looking at this, we see that a sub to n times a sub to n plus 1. So there are quite a few terms here. Minus 2 times a sub to n. It is 1 minus 6, as we say, 1 minus 6n over 1 plus 6n. Okay, but given the values to n to find, for example, different values here, we will see that the value of the fraction on the right will start decreasing. So, for example, each value, value, let's write the solution. For any value gamma 1, it will be greater or equal gamma 2, gamma 3, gamma 4, like this. So it's the fact, because looking at the right hand, we can easily notice it. So it's kind of signal to us that this given sequence is non-increasing or decreasing. So why I wrote non-increasing, because I just consider all the facts, possibility of non-increasing fact. Sorry. Okay. So if it's fine, we can now go further. So, and actually it's easily not zero, because this part, this product must be greater than this product. But here we see, something different. That means, of course, the given sequence is either decreasing or non-increasing. So it means, but we know that decreasing and convergent sequence has a limit. So it's the fact. So that sequence is convergent. Okay? So we know that this sequence is monotonously decreasing. But also, should be bounded by a value. Because this expression, we see that this expression is kind of limited by a value. So what it means is to understand that for the greater values, for greater terms, not greater terms, for more terms of the given sequence, for example, sequence a sub to n plus 1, so and for the sequence a sub to n, so their limit will go to the same point because they are both decreasing. So this sequence decreasing and this sequence is also decreasing. So that it doesn't matter how long you keep the sequence or you open it. The result is they will both get decreased, so they will go to actually the same value. Okay, that means so a to n equal greater than a sub to n plus 1. So that means just the given sequence is limited. Okay, so we can actually find it means it's bounded, it has limit, it's convergent. So let's find that limit. So if so we can believe that as n goes to infinity, the sequences will be somehow the same, will be equivalent. So instead of a sub to n plus 1, we can take here a sub n. If we can write the given expression will turn into a sub to n times a sub to n minus 2a sub to n equal 1 minus 6 plus like this. So it will be just nothing but a sub to n squared minus 2 times a sub to n equal 1 minus 6n over 1 plus 6n. That's fine. So okay, now the second change, let me come here. So this expression, if I go here, it will, by adding 1 to every side, it will be a sub to n squared minus 2 times a sub to n plus 1 equal. So I will have to add 1 here too. So it will 1 minus 6n over 1 plus 6n plus 1. That's fine. So, but this part will give me what? Will give me nothing but, actually I can erase this part because I have no any space. So let me erase this part to continue here. Okay, let me continue this part here. So let me come here. So this will be nothing but a sub to n minus 1 squared equal. So by adding 1, I will get here 1 plus 6n here, 1 plus 6n here. Let me just separate. It will be just 2. So I will get this expression here. Yeah, that's a fact. Because by adding, I will get. So let's erase all the stuff here to continue with the final result. So my result here is sub to n minus 1 squared equal this expression. So if I get square from both sides and consider that this expression is, natural numbers, has terms that are natural number. So I can write like this: a to minus 1, 2 over. Actually, it matters here. It doesn't matter actually whichever I take here. Okay, like this. So from this, a sub to n equal 1 plus 2, 1 plus, like this. So this is the final result, but the result I have to find is the limit of a to n goes to infinity. Okay, let me change a to n index to n. So it will be, so it means I have to write n over 2 wherever I see n. So it will be a sub n, because 2 times n over 2, they will go, the n will be left here. So 1 plus 2 over, it will be 3n just. Okay, here's our result. So an is kind of expression. But actually I have taken minus because here it can be minus 2. So just let me add here. So we can also take minus because it's decreasing function. So actually we should better to take here negative. Okay, anyway, so our expression, our limit will be limit n goes to infinity, a sub n equals limit n goes to infinity. So I should take minus. So 1 minus, doesn't raise this button because I have no space. 1 minus square root of 2 over 1 plus 3. So the result, it's all the same. The result is 1. So here's the result. So I think this is a nice problem. So of course we didn't try to find the actual expression a sub n from the given facts, because in that case we may have got into trouble because we don't know. It's a really complicated expression, but we know that this expression left side is decreasing. It's fact, because right side is decreasing. It gets here negative values. So it means actually it already tells us about the nature of the given sequence. It's also decreasing. So we just applying. Remember that fact. We applied all the facts and finally found that this limit is 1. I think this is a brilliant problem. So this problem may shed light on other guys' problems and work to achieve greater results soon. Okay, this is the result. I think it's really understandable. Okay, I won't stop here. See you guys.